I'm James, and I'm here today to talk to you about native apps. I have a background as a software developer, but I guess I consider myself more of a generalist. I got into the data and analytics world probably about 8 years ago. I've been a Snowflake data superhero for a number of years due to my contributions around that ecosystem as an early customer. And then I co-founded a company called Omnata about 2.5 years ago, and it's launched and based here in Australia. That's our website there on the right. We position ourselves as no middleware data integration products, which really means that we build native applications. So we've had a Salesforce native application in market for about 2.5 years, and we've been working away on a Snowflake native app which has just entered private preview following Snowflake's recent announcements. So today I have only about 20 minutes, so I'm going to establish what a native app is, how they might be designed differently as a product, sort of architecturally, and also how you might go to market differently. I won't pitch our product too much. I might mention it if it's in support of the topic. I mainly want to share my perspective on what native apps means for data products in particular. And I'm going to finish up with what's next. And, I don't mean vaguely what innovation might be on the horizon. I mean immediately and practically, on Monday morning, back at your job, how might you work differently, particularly if you're a Snowflake customer. So, in the largest possible meaning of the word, a native app, if you look at that top line there, it's a software program built for a particular platform or device. But often these days, people also mean some kind of storefront for distribution, which is directly linked to that platform or device. And then beyond operating systems, you might have noticed most of the larger SaaS platforms have started allowing vendors to build stuff of what they've built. These can be anything from little widgets to fairly large features to entire products. And Salesforce is a good example. They've had a lot of success with vendors building entire solutions for a particular industry vertical, which has gone on to become fairly dominant in their market. But now we have data platforms launching their own take on this, which is a whole different thing entirely, really. And since we're at a data engineering conference, it makes sense that this is the type of native app that I'm going to be talking mostly about. I'm going to focus on Snowflake's new offering because, as well as being a data superhero, I know this framework really well. I've been building on it for about a year. As far as I know, it's the only one of its kind today. But I think it's safe to assume that the other major players will come up with some similar or equivalent concept. For those of you who have no idea what I'm talking about with Snowflake native apps, because it's a fairly new announcement, I don't really have time to tell you what it is. There's plenty of good talks online about that. The gist of it is Snowflake now allow you to package up code and deploy it into a customer's account as a vendor using what's called an application package. Discoverable on the marketplace, and it's just entered public preview. So when I originally submitted this talk, I hadn't yet been to Snowflake Summit, and I hadn't seen this 20-minute talk by Ben Stancil. To summarize it, he talks a lot about how he's a data product founder as well, in case you haven't heard of him. He talks about how these product companies have to raise a lot of money to cover their large costs of development. And then that tends to shape them from day one, forcing them down a path of, over-focus maybe on the enterprise end of the market, and also feature bloat, where they're trying to satisfy a lot of different use cases. He's quite bullish on native apps. He lays out some good arguments about why you should be interested. He parallels it with the success of like iOS and Android apps, where the platform gives you all this great base functionality as building blocks and a distribution channel. And so you can take a smaller team and focus on a smaller market and still have a really good business building products that customers really love. He uses the example of Midjourney as something to aspire to. They're a product that's built entirely as a Discord app. They have something like 15 staff members doing probably tens of millions in revenue, so very successful. I use Midjourney for some of the slides in this, you might notice. So think of my talk as a sequel to this one. So assuming you agree with that premise on the opportunity size, then what next? And how do you start thinking about a data app product? So talking about product design and how you might think about a data product in a different way to a regular app, I'm breaking it into these three flavors. So the first I'm calling platform tools. So this is a tool which is designed to work with your company's data warehouse. It typically does something universal or general with your data. Maybe it governs it, builds a catalog, measures quality, helps with performance, audits access, all those types of things. This is what a lot of data products are. They're these cross-cutting concerns across your whole data warehouse. And there was an argument being made, especially last year, that this so-called modern data stack was becoming too disparate. And while it was great to have these specific tools that were way better than their equivalent feature on a larger platform, it was starting to become at the cost of getting them to play nicely together. And Anant from Data Engineering Weakley rightly pointed out that people like to draw this parallel with the Unix philosophy, but he sort of points out, task specialization is not the only criteria to make something, part of that category. And so if we look at the typical tenets of the Unix philosophy and compare them to like the data products we've seen over the last few years during this unbundling phase, in terms of writing programs that do one thing and do it well, they certainly do that. And the second point, to some extent, they do work together well. They're usually eager to be interoperating with each other. But for the last point to me is the most interesting, because this talks to this kind of operating system angle of what's tying them all together. What do they share in common? And we have to tweak it a little bit because we're not talking about Unix, files and streams and sockets and processes anymore. We're talking about structured data usually. So these products often don't have a neat point of handover to each other, aside from just calling each other's REST APIs to trigger the next thing. And this is usually because they're designed to support all of the data platforms. So naturally they sit outside of it and act as their own thing. And so working together isn't about making your orchestrator make a bunch of calls to all these different products in the right order. Really, to me, it's about the data staying on platform and flowing through these well-defined interfaces for each workflow. And each product shouldn't be operating at arm's length from the outside. They should be lost my mouse. Everything should be on platform. And so with Omnata, as a quick example, we're doing ETL and reverse ETL, but everything's managed via tables in the customer's account on Snowflake. So we're tracking the state of all the records that have been synced, all the historical activity, API responses and things like that are all stored there. All the operations are driven through SQL interfaces. So if you want to test if your data is valid for where you're going to send it, you can call a UDF to do that. If you want to start a sync or cancel or pause, you can call a stored procedure. And these are all the same stored procs that our Streamlit UI calls, our DBT package calls, or anyone else can call. So it's all very much unified around Snowflake primitives. And similarly, if you want like a nice user-friendly way to search for, say, a particular customer, where they've been synced to which systems over time, you can use our UI, or you can query the table yourself, depending on what you prefer. The second flavor of product of the three that I mentioned before are these kind of industry solutions. So some products aim to pick a specific use case which happens to involve a lot of your data, and then they solve that kind of end-to-end for you. And this is a product named Clary. I've never used it. I'm certainly not picking on it. It just came up as a popular end-to-end solution for sales managers to understand what's going on with their sales team, predicting revenue and tracking towards it. And it kind of does everything for you in that space. So it will ingest a whole lot of data from different products into its data store, perform a bunch of internal transformation and analysis, and then it's going to present insights in its UI. The way I would reimagine this as a native app would be less of a self-sufficient black box and more like a templated transformation pipeline that you can hook into with a bunch of canned visualizations as well. So for starters, ingestion I don't think would even be part of the solution. You could use existing ETL tools and whatever else you already have in the warehouse, because those data sets are likely used for a bunch of other reasons anyway. And then something like a revenue forecast would be a data set generated by the functions or stored proxy in the native app, and then exposed to the account that they're in, and then the visualizations will be built over those. And I guess the benefit of having the forecast table as an artifact itself, you can easily then integrate it into other areas downstream, like board reports or CRMs and things like that. The third flavor that I mentioned are the data utilities. So these are actually smaller pieces of functionality that were never products before, probably because there's too much overhead to creating a data product. I think this is an area where we waste a lot of productivity on. There's more niche tools. They fall into this no man's land between building and buying. Things like parsing data for a particular industry, custom visualizations and dashboards. A heap of companies end up building it themselves and supporting it at a much greater cost than if they just pooled their resources together. So for everyone's benefit, I'd love to see that line move a little more to the right. In other words, we build and support less bespoke stuff. As far as going to market, it's hard to talk about data products without doing a little tangent into open source, because I think it's going to be interesting to watch open source evolve around this change, because it's always been impacted by deployment models. And just to dig into that a little bit more, I love that Mid-Journey picture that I'm pretty sure that it's a made-up piece of equipment on the wall, whatever it is. The early days of open source, there wasn't a lot of commercialization, so mostly personal and academic use. You were a little more self-sufficient back then. And in the 2000s, gaining commercial popularity, but there was no cloud. Everyone ran their own hardware. So companies like Red Hat selling enterprise support contracts. And then in the last 10, 15 years, people started to no longer want to manage their own hardware. So they started packaging these products up on, say, the AWS marketplace, something of a semi-managed service. And then other companies were playing the long game and pushing more into SaaS. But both of these were highlighting the trend that there was going to be more money in fully managed offerings than in just pure support contracts. Of course, you run into the problem where other people might sell your open source product as well, so you end up competing with them. We saw that with AWS, companies like Elastic and Confluent and MongoDB had to switch their licensing models to stop competitive managed products, so that's a bit tricky. But then after the success of particularly Hadoop and Spark and all the big names in open source, this model emerged where people would toil away on a free offering with really good community support, and then use that community as a proof of traction to raise VC funding to then launch a cloud offering of that thing. Those products have the same threat I mentioned before, that somebody else could compete with them commercially. Or the other strategy might be to split the product up into like a core open source part and then a commercial other part. That's a tricky balance because the core has to be good on its own, but the upgrade also has to be worth it. Not easy to do. But my point in saying all this is what happens if a chunk of the market, particularly this enterprise end that everyone's keen to deal with, start saying, well, we don't want you managing our infrastructure anymore. We'd much rather you ship your product as a native application for security or privacy or reliability reasons. It's really hard to open source a native app without also giving away the ability for people to kind of run it themselves. And this is something I've thought a lot about, experienced it firsthand. Someone once asked me, why don't we open source our stuff at Omnata? And I had to say that I'm not really sure how I would get paid if I did that, basically. Can't sell infrastructure, don't really want to sell support services. So I think we might see, if native apps gains traction, we're going to see maybe a shift in licensing strategies. I think it'll be harder for VCs to subsidise open source projects early on if it's unclear how to commercialise them later. And so people will have to think more carefully about why a product should be open source. Does the marketplace magically bring customers to you? I can say from our experience with Salesforce that it absolutely does not give you an automatic source of leads. You still have to, you can't just list it and sit back. You have to engage with your market, still have a website and all those things. The marketplace is really just a storefront to send people to. But what it does give you is global deployments instantly. Australian customers know better than anyone else how annoying it is to wait years for something to arrive onshore. It gives you a billing system, standard legal terms, all these useful building blocks for a startup to launch quickly. So to wrap up, Snowflake's native app framework is now in public preview. So what's the best way to think about using it other than reading the docs on how it works? I would encourage you, if you're building something for internal use at your company, get into the habit of packaging it up as a native app, even if you only intend to deploy it internally. It puts this neat little boundary around what the thing does, and it forces you to stop blending it into your environment too much. Pardon me. And if you're dealing with consultants or external agencies to come in and build things for you, have a chat with them about whether they could build it as a native app. So rather than just build it for you at the maximum possible cost, maybe you can agree with them to be their first customer, co-develop it with them, and then get a better long-term outcome for less cost. My voice is giving out, so I'm glad we are at the end, but I'll still take a few questions if anyone has one.
Round of applause.